Hello everyone, welcome to our new video in R programming. We continue in this video with our statistics, fundamentals and applications. So there are some databases, data sets that are available in R we can use in our examples. So if we type data, we can see the list of these data sets, and in our example here we are going to use the cheek weight dataset, this one, and if you run it, basically you will see the data set which contains these two columns, weight and feed. We have 71 observations and two variables, as we can verify. And also notice that by using the $sign we can access these columns one by one. So if we want to access, for example, the first, let's say 20 rows for both columns, then you can run this one and this will show you the first 20 rows. But if you want to select, let's say, the second column, the first 20 rows, then you can choose from 1 to 20 and write the second column, and you will basically display these values. So let's change this to 1 to 20, or you can select any region that you want. I mean, from 5 to 20, the row numbers, and you might want the first column, then this is what you will run. And as I mentioned, just basically using the $sign, you can access different variables. The weight, you can see this is the weight column, or alternatively we can access the feed column by using the $feed here. Of course, there are other data sets that we can use. For example, we have the quakes, which is a data set giving us the earthquakes information. And in this data set, you can see we have 1000 observations and 5 variables with these names referring to the latitude, longitude, depth, magnitude, and stations, measuring some earthquakes in a certain location. So if you want to create a simple plot, for example, showing the longitude and latitude of these earthquakes, you can type plot and enter these as your X and your Y axis. Then you can put some labels to your X and Y axis. So if we want to create such a plot, this is what it will look like. You can make this smaller or larger, and you can also add more like titles and other, you can change the color, etc. Again, as usual, if you want to access to a specific variable by the name, then use the $sign, like this example here. This shows us the complete column of basically the earthquake magnitudes are given. You can do some simple statistics calculations, such as the mean standard deviation of your variables, each column. For example, this one is taking the average for the magnitude of the earthquakes. We can see that the average magnitude is 4.6 to 62 in this data set. The average depth, if we want to calculate, is given by 311.37. Similarly, you can calculate the median. So these are, you can extend these examples to another data set as you wish, and we can see the median value is given for these two different variables. Basically, when there's a small note here, if our data set, in our data set, if we have outliers, then the median is going to be a better statistic to calculate the center of the distribution of these points. So if usually if you have many outliers, you might prefer the median as a measure of the center location of your empirical data set. And another useful function in R is given by this table function. And if you input some sample to this function, it's going to produce you basically this X table. We can see the frequency distribution of the magnitudes of earthquakes. As you see, I input this data directly to this function, and it produces us a nice table so that we can see what's the most frequent earthquake magnitude in this location. For example, we have 1 of 7. This is the highest frequency. So most of the earthquakes in this sample are coming with magnitude 4.5. Okay, it has the highest frequency. Other simple operations you can do, you can have a sample like in this X, just an arbitrary vector of numbers here. We can calculate a minimum or maximum using these basic functions. Again, you can apply this to your data set, built-in data set as well. Directly use the $sign if you are working with a specific variable. And we can calculate the minimum and maximum depth for these earthquakes. And similar to the range function, it will give you the minimum and maximum directly, both of them. So if you have a sample like X, if you call range X function, then you will get the range of X range of values in this sample given by X. Alternatively, you can apply this to some data sets in R, calculate the range of, let's say, earthquake magnitudes. All these are basic operations, but you will be using them a lot when you do a statistics application. And in some cases, our data set obviously might have some NA values or NANs that are given here. In that case, for example, I have this X with an NA value in the 4th location. Then if I calculate the mean of X, I will get an NA. And similarly, if you use another function such as the median, again, you will get NA value. So the question is how to handle the NA or NAN values, because we might have some missing observations with NAN, not a number. But we still want to be able to calculate the mean, the median, etc. So in that case, we will still use the mean function, input our X, but this time we will say NA remove equals to true, so that it will not consider the MA, and it will still perform the usual calculation of arithmetic average or median as before, without being affected by this NA or NAN values. So this is a useful method in R. As you see, we can basically avoid having some problem in our calculations. Again, I have some other examples here with operations on subsets in a data set. So we have this data set here, the cheek weights data set. This time we are doing example with this one. And this column, this is the type of feed given to the chicks in the population, in the sample. And these are the categories of feed. And basically, for example, you might want to restrict your attention to the weight of the chicks in a specific diet, like the feed type, let's say is soybean. So I can condition, I can find the chicks that are fed with the soybeans first, and then display the weight of these only. Okay, so you can see these are the weights of chicks that are fed with soybean. So if you want to do some calculations like mean, the median, etc., or standard deviation, then you will be basically specifying this condition first. So if this is for these equality, this logical operation, if this is true, then you will select those indices in this column of chick weight. And then finally you perform the calculation of the mean. Okay, so this is the mean of the chicks that are basically fed with this casein, or you change this to soybean, etc. So these are selected first among these chicks. Then we take the weight of these, we calculate the average weight of these specific chickens, basically, or chicks. So you can try these examples in different data sets again as well. But this is a useful operation since we can work with different subsets of the data set. So instead of, for example, doing this one by one, there is this tapply. If you want more information, you can also use the you can also use this question mark and apply a function over a rect array. This is a useful R function, and in this function we can actually first input our data that we want to work on. So we want to work on the chick's weight, and I can specify what kind of operation I want to perform on this variable. Suppose I want to calculate the mean. So now I can change this index, so you can consider this index just like as a variable, and among these different categories in the chick weights data set, the type of the feed, as we change this type of the feed, this index will change, and we will be restricting our mean calculation over this subset each time. So this will, as you see, this will give us this index is changing, is starting with the first feed, second type of feed, and so on. And each time the function is applied on this restrictive subset of the chick weight column. And similarly, you can apply other functions, such as you can simply take maybe the sum of these chick weights in each specific subset. Then you can see this way we can see which average in which group the average weight of the chick is highest, right? So we can observe that easily. And there are some other functions, such as the round function. This is used for rounding. So we can round with 2 digits. For example, we can specify the number of digits that we want to display our results. So there can be rounding. For example, here we can see basically this is giving us the percentage of the chicks that are fed with each of these different material, right? So like 17% is in the first group, 17% is in linseed, etc. And we are showing these percentages with some rounding. Okay, so without rounding, for example, if we didn't round it, we can delete this part and simply show it like this. But then this will be a bit too long, to display. It's not convenient. So it is better, I think, to display with some rounding, so it is much clearer. And basically you can apply with different data. We can still show similar examples. And then next we can introduce the quantiles in a data set, because here we are talking about descriptive statistics of a data set, of a sample. And in one of the statistics we can calculate is the quantile. So the quantile basically specifies a point in our domain that corresponds to a certain probability. So, for example, if we look at to the 50 percentile, this means, let's say I calculate this, but first I need to define my data. So let's run these two lines. And then the 50 percentile actually corresponds to the median of the data set. So it's going to be 2.6 for this example. Okay. So that corresponds to the median, and it depends if you have odd number of observations in a data set, then that will be the midpoint. But if you have even number of observations, then you will take the average of two neighbor values in your sample. But of course, we need to first rank the sample and then find the midpoint that will correspond to the median. Okay. The calculations and more explanations about the basic statistics can be found in any kind of textbook actually. So I'm not going over the theoretical explanations here, but you can calculate, for example, the first quartile. This is known as the 25 percentile of the sample set, and basically that corresponds. If we define quartiles, you can think them as 4 equal regions of the data set, such that in each region we have the same number of observations, or roughly the same number of observations in each quartile. So we divide our sample set into 4 pieces, where the probability of each piece is 25%. Okay, so these are called as the quartiles. So we will have equal number of observations in each quartile. Okay, so the probabilities are roughly, the probabilities will be 25% for each quartile. So you can calculate these quartiles basically for 25%, 50%, and 75%. For example, for a given data set, if you want to display the descriptive statistics of this data, it is a good idea to show these points, the quartiles. Like this one, it will show us the values, for example, from 2 to 2.6. This range contains 25% of the data. Another 25% is included from 50% to 75%. So these are the corresponding X values in the domain. Okay, so in R, we can easily perform such calculations to display the descriptive statistics of a sample to the user. Another useful function available is the summary. You can use this function, let's say, to summarize the quartiles, the minimum, maximum, and of course the 50% quartile is same as the median. Okay, so this can be given by just using the summary function, so it will be more convenient. Alternatively, you can again restrict your attention to a specific subset of the data. You don't have to work with the whole data set. Maybe you are interested in the earthquakes with depth less than 400 kilometers. Then you can put this condition, and basically the data set will be selected only for this logical operation to be true. When this logical operation is true, we will pick those observations and we can calculate the summary statistics. Okay, the summary statistics basically again gives us the quartiles and the minimum maximum information. So this is the whole basically sample for the depth of the earthquakes. It can be given here. So we have seen most of the basic statistical concepts here for descriptive statistics. You can also make different plots. There's another example here with the x and y values. Suppose we have this hypothetical data set with x and y values. The average for x and y, they are both the same. If you want to display this data, the x data, which is our sample here, you can create this plot. Okay, so this is now, since we set this type to n, okay, that's going to be null. Okay, there is no point or line displayed. So currently it is null, and then we can fill these step by step. As you see, we can add some lines to our plot, or we can display some text at a specific x and y coordinate. So we can define the start and end point of our text box with these labels. So if we, for example, now run these two lines first, so we can see it will show us these horizontal lines. Okay, the line type equals to 2 gives us this dashed line, and we have the gray color, etc. We want the horizontal lines from passing through 3 and 3.5. You can also add a vertical line to your plot. If I run it, now I have also added a vertical line. So you can try these step by step going forward and see how do we upgrade, enhance the plot. Now this time we have this we have the text written as x and y at these locations. This is the coordinates for my labels that I added here. And finally, if you want to add the points, so this jitter function is adding just some noise to our observations, and we will be displaying the points finally using this points function. Okay, so we added these points given with our x and y coordinates here, and jitter function, we just added some noise to these observations actually. Okay, so we have done several examples involving plotting and also some descriptive statistics. That's all for this video, and thank you for watching.